of you guys fill in for 0, 1, 2, 3, and 4. Who can tell me the y values after looking at the calculator? Go for it, Trent.
No, I need to.
You need a pencil.
I mean, 5.
I just called you Tristan. Tyreek.
5, 0, -2, -4, and -3.
Good. 5, 0, -3, -4, -3. Perfect. 2 got that. Give me a thumbs up. Awesome. So then you go ahead and graph it. So 0, 5, plot 1, 2, 3, 4, 5, 1, 0, 2, -3, 3, -4, and then we just kind of continue the pattern. So it should look something like that. So looking at your table, who can raise their hand and tell me the zeros? Who can tell me what the zeros would be? 1 and 5. So if remember, zeros means your x-intercept. So I look right here and go, oh, here's one of my zeros, 1, 0. And when you get to 5 on your table, it was 5, 0. Perfect. So remember, zeros are your roots, your solutions. They all mean your x-intercepts. What about your y-intercept? What's your y-intercept here? 0, 5. So remember, OY, right? So 0 and then 5. That's your y-intercept. They just happen to be the same number, but those are not the same point. Who can raise their hand and tell me the vertex of this parabola? Go for it, come on. 3, -4. And so you could either find that by looking at your graph right here, it's the very bottom or very top, or I can look and see, hey, this is what we did yesterday. It goes from a number to a different number back to that same number, so I know that this coordinate is my vertex. What's your axis of symmetry? Good, x equals 3. Remember, it's an equation, so it splits it in half, and it's the x coordinate of your vertex. What's your leading coefficient? Is it positive or negative? She's smiling or frowning? Smiling, right? So she would be positive, Patricia. So we know it's going to be positive. Does this parabola have a max or a min? What is it? A min, right? Because this is the smallest point, and your min is the y value of your vertex. So your min is y equals -4. Cool. So that kind of sums up, at least using a calculator, how to go about doing this. We also learned yesterday how to do it if it's not on our calculator, which means decimals. We would use the quadratic formula and the axis of symmetry and vertex equation. So, circle how you feel. What we're doing today is we're doing word problems. So we're learning how to identify what's being asked from word problems. And so sometimes you'll be able to use your table on your calculator. A lot of times what you're going to have to do is you're going to have to use the quadratic formula or vertex formula. And I'll show you 2 examples of that. So first thing is you're getting out that little, it's like a third of a sheet of paper, it looks like that, of your notes. And so we're just going through key phrases that we would know what's being asked. And I want you to draw like a little person like this, because usually quadratic questions are kind of usually about someone throwing a ball or throwing something and looking like that. So you're drawing that right on your paper. So either on the back, or you can draw it like right where it says y-intercept, so it looks like mine. And so quadratic equations are usually about like someone kicking a soccer ball or someone throwing something off a roof or something like that. So you want to make sure you're writing these notes down, because usually these are the type of problems you're going to see on your milestone. So just bringing everything together. All right, first is your y-intercept. And so your y-intercept is usually your initial, your starting, and in most cases, it's usually referring to your initial or starting height. So I'm color coding right here, so I can see right here, his starting height is his y-intercept. So when they ask about a starting or initial, something like that, your height, they're usually referring to what is the y-intercept. They're not always going to say what's the y-intercept, they're going to refer to it like this in a word problem. When they're talking about x-intercepts, other words they can use, we already learned, are zeros, roots, and solutions. But usually when they're talking about word problems, they're referring to when something hits the ground. So like right here, when the ball like hits the ground, or like if I'm kicking a soccer ball or I'm throwing a football, right, and it hits the ground, that usually it means they want to know what the x-intercepts are. It also refers to the time it's in the air. So if I'm kicking a soccer ball, they want to know the time that it was in the air for. So by the time it hits the ground, that could also be referring to your x-intercepts. So I would color coded it right here. It's always going to be your positive x-intercept in word problems. So although we have 2, I can't kick a ball in -5 seconds. That does not make sense. So it's always going to be the positive answer. So I'm going to go to vertex real quick. Vertex is your coordinate of your highest or lowest point, or max or min. So it's like the very top, the very bottom of the graph. Your min or max would be the height of the max or min. So like if I'm going to kick a football or kick a field goal, right? The part that is at its highest point is your max or your min. So like right here, like if this is the very, very top, this part right here is your max. Last is your axis of symmetry. It's your x-coordinate of your vertex. But in word problems, it's referred to the time it takes to get the highest. So like if they're referring to your axis of symmetry, they're referring to this right here. So like the time, how many seconds it took to get to your highest height. So like if it's asking about the actual height, it's your y coordinate. If they're asking about the time, then it's your x coordinate. Cool. Does that make sense? Yes, no. Okay. So now what you're doing is we're starting at the back of that packet. Does everyone have a packet for today? Does anyone not? Okay. So you're going to the very last page that looks like it looks like this. So you're going to the very last page of that packet that looks like type 4. And so the first thing we're going to do is just identify what they're asking for. So like first one says, I'm going to do the first one with you, and then you guys are going to practice. I'll give you a few minutes to do the rest on your own, and I'll just cold call. So This says Jack wants to know how high the soccer ball will get if he kicks it straight up in the air. What would that represent? Which thing? Would it be your zeros or your x-intercepts, your y-intercepts, your max, or your axis of symmetry? He wants to look at the height of the ball of how high it will go. Max. Y-intercept would be like where it starts. So if it starts at the ground, that would be his y-intercept. But if he wants to know how high the ball is going to go, this would be my max. That's all you're doing. The next one says, I'll do one more. Lily wants to know how long her toy rocket will be in the air. So if she is figuring out, so if I'm throwing this, right, now I want to figure out how long it's going to be in the air. When would I know when it's not in the air anymore? I just threw my pen, right? How would I know it's not in the air anymore? When it hits the ground, right? So when I throw this up, I know, hey, it's not in the air anymore because it hit the ground. So when something hits the ground, what are you looking for? Good, x-intercept. Does that make sense what we're doing right here? So all you're doing on this first page, you do the next floor, and I'm going to just call. You're just identifying what they're looking for. So first we're just practicing like what are they looking for? Then we're going to practice like actually finding it. But first it's important to figure out, okay, what are they looking for? First one. Nancy is trying to find how many seconds it will take a golf ball to get to its highest point. Good, because it's the seconds, right? And so because it's the time, it's your axis of symmetry. Beautiful. Tristan, next one. Bill is wondering how long it will take a football to hit the ground after Tom Brady throws it during practice. Beautiful, because when it hits the ground, it's your x-intercept. Perfect. Kimberly, Sally threw a ball in the air. Sally's friend wanted to find how high the ball got, given that it took 1 second to get to its highest point. Axis of symmetry would be your 1 second. Anyone want to help her out?
Right.
Your max. So it's the y coordinate. So your x coordinate of your axis symmetry is 1 second. But if they want to find the highest point, that would be your max. And then last one, Yaslin. Ray found that the max height of a basketball thrown from a half court to be 21 feet and wants to know how long it took to get there. What did you say? No, y-intercept. Michael, axis of symmetry. So it would be axis of symmetry because they want to know how long it took to get to the highest point of your axis. So remember, y-intercept is like you're starting. Like if I'm 5'2", because I'm really short, right? And I'm throwing a basketball, my starting height would probably be a little less than 5'2", because your hands are not, I'm not usually throwing a basketball at my head, right? So that has to do with your y-intercept, your starting height. Or if I'm standing on that desk, right, my height's going to be a little bit higher. That would be your y-intercept. Okay, turn to the back. And so now all you're doing is you're doing the same thing. And so I'll go with you. So the time it takes to get to your highest point, what would that be? Michael just did this one. What did he say? What was his answer? Axis of symmetry, right? And so which would I use to find my axis of symmetry? There's more than one answer. So it's a bunch of, so would I use the axis of symmetry formula? Negative b over 2a. Could I use that to find my axis of symmetry? Yes. And what coordinate is of your max is your axis of symmetry? Is your x or your y coordinate? Axis of symmetry. X coordinate. So I would read the x. I would not read the y because that would be my height. The zero function, what does zeros mean? X-intercept. So it couldn't be that. use the axis symmetry formula, but then plug it back into the equation. What did we learn yesterday? What does that represent? When I do negative b over 2a and then I plug it back in. The y coordinate of your vertex, right? So it couldn't be that. Quadratic formula, what does that get me? That's what we learned first period yesterday. I wasn't here during that period, so I'll give him a pass. But does anybody else remember what's the quadratic formula give us? X-intercepts. So it couldn't be that. And use the value function that's talking about your y-intercept. So those are my two answers. So right now you're going through. Brandon, you want to do the first one? With the highest point, what does that represent? Yeah, and what coordinate your vertex?
Max.
Your max, right? So which letters would I use to find that? There's two of them I would use. What letters did you circle? C? Mm-hmm. What's the other one? B would be axis symmetry. What's the other one to get me the y coordinate of my vertex?
C.
Okay. Anyone help them out?
E.
E. Where I use that equation, then I plug it back in. Good. All right, next one. How long an object is in the air? Tanya, what would that one be? What would that represent?
Oh, X-intercept.
Come on.
Oh.
X-intercept. Because you're figuring out how long until it hits the ground. So, Tanya, which ones would I circle? There's just two that I would circle. Which ones would give me my x-intercepts? D, because 0 is mean your x-intercept. And what's the last one? Not A. A would give you your x-coordinate, your vertex. Anyone help her out? What other letter? Mark?
D.
Not D, though. What formula gives you your x-intercepts?
Oh, yeah.
F. Remember, the formula, the quadratic formula we worked on yesterday during first period always gives you your x-intercepts. Cool. Last one, when it hits the ground, Jordan, what would that indicate? Jordan. What does that one indicate? Which one is it? Is it not the letters? I want to know what it is. What does it stand for? Is it your y-intercept, x-intercept, axisymmetry, or max? When it hits the ground. Not the max. Anyone want to help them out when it hits the ground? Front. X-intercept. Remember, when it hits the ground, that's when it stops, right? So that's your x-intercept. And same as before, which two do we use to find the x-intercepts? My D and my F. They always give you your x-intercepts. Cool. So, last thing we're going to do is we're going to look at examples. So go to the front, the very first page, and we're going to go over an example together. So go to this one right here, and I need you to cross out that equation and write the equation that I'm going to write on my board. So f of x equals negative 16 x squared plus 24x plus 6. So make sure to cross that first equation out and write that one on the very first page. So it says a volleyball player hits a ball over the net. She hits the ball from a starting height of blank feet. The ball reaches its max height of blank feet in blank seconds. No one from the other team is able to hit the ball, so it hits the ground blank seconds after being hit. So first I'm starting with my starting height. What does starting height indicate? Y-intercept. So first I need to find my y-intercept. This is in standard form. What number is my y-intercept? You can type it in your calculator, but you should be able to see it looking at it. 6. Remember, it's your constant. So 6 is your starting height. So I would go right here at 6, and here's the ball, and that's her starting height. So right here, starting height of 6 feet. Then I want to know what the maximum height is. So what does that indicate? And the seconds to your maximum height. What are those two? What is the seconds? Because I have to find that first. Axis of symmetry. If you were to put this in your calculator, it is a decimal, so it's not going to show up. What's the formula that we need to use to find the axis of symmetry? Anyone remember from yesterday? The axis of symmetry equation, what did we use yesterday if we can't find it in our calculator? Good. It's negative b over 2a. It's the outside of your quadratic formula. So negative b over 2a. What is your b here? Good, 24. So I put parentheses where I'm plugging in. And then 2, what's your a? Negative 16. Put that in your calculator and see what you get. 3/4. What's that as a decimal though? 0.75. So I would go to 0.75, which is right between these two, and I know that that's going to be the seconds it took to get to the highest point. So in 0.75 seconds, I know that my ball's at its highest point in 0.75 seconds. Now, what do I need to get what the actual height was? Plug it in. So I take my original equation, and instead of the x's, I'm going to plug in what I got for x, which is 0.75. You're putting that right into your calculator. So with the parentheses and all, instead of my x, I'm going to put 0.75, because I know that is the amount of seconds it took to get to its highest height. So put that right into your calculator and see what height you end up getting.
If you have it typed into your table already and you don't like using the parentheses, you can always, after you hit enter, you can do ask x instead, and you can type in the x value you want it to find. But that's just if you don't like typing it in.
What do you end up getting, Kumar? 50. And so even if you put it in your calculator, and you put 0.75 for that table where it says S, it would give you 15. So I would go right here, and here's where the ball reached its max height, 15 feet. No one from the other team hits the ball, so it hits the ground. Now, if I were to look in my table, it is a decimal. So what equation did we just go over that to find our x-intercept when it hits the ground? What formula did we go over yesterday if it doesn't show up on our table? And we went over it just now, too. There's the cube. Quadratic formula. So remember, they're not going to just give it to you. It is on your formula sheet, though. So that negative b plus or minus b squared minus 4ac over 2a. And so some of you guys plugged it right into your calculator and would rather do that. Some of you guys wanted to plug it in and simplify. Whichever way you're using, do it. And make sure you're only looking at the positive answer. So if you get a negative answer, then you have to do the other function. So I'm just going to plug in my A, B, and C. So I'm going to rewrite it like this, like we did yesterday. And this is also an example of when you would have to do it completely by hand, not by hand, but completely without the table. Most of the time, you're going to be able to just look at the table like we did on our ticket in the door and find it. So for all our A's, we said our A was what? Good, negative 16. What's our B? 24, and our C? 6. So now you're going to go down here, and all the A's, I'm going to plug in negative 16. All the B's, I'm going to plug in 24. And all the C's, I'm going to plug in 6. You can type that right into your calculator, like use plus first and then change it to a minus. Or you can simplify it to make it a little bit easier. Just make sure you use plus or minus. A lot of you guys are just not putting a sign there at all. And that's why you get the wrong answer.
Who's the middle sign we put?
Put plus, and if you get a negative answer in the end, the negative decimal, then change it to minus, because it only can be, I can't do something in negative seconds. So use one or the other first. So if you're going to use a plus, put a plus in first. If you're going to use minus, put the minus in first. So try it using your calculator. If you're going to simplify it, you can simplify it. So to do that, I'll just do that under here. I know the opposite of 24 is negative 24. And I could go, okay, 24 squared is 576. I can see there's 2 minus signs, so I'm going to turn this to a plus. And then 6 times 16 times 4 is 384. All over negative 32. And so I can keep combining it until it gets a little bit smaller to type in. Did anyone get the answer yet? So let me know if anyone gets it.
1.7.
It is 1.72 or 1.7. That is the positive x-intercept of your function. So I go like right here between 1.5 and 2, and that is where the ball hits the ground. So when I'm drawing a picture, it looks something like this. It hits its max, and then it falls right there. So it's just kind of combining everything we've done in a word problem. Does that make sense? Okay, let's try one more, but now we're going to be able to just use the calculator. Actually, we're not. So let's look at this next one right here. I'm going to erase this. And it says, a ball is thrown in a height above the ground. At any given time after the ball is thrown, t measured in seconds, it can be modeled using that quadratic function. First, they want us to draw a picture. So first, you're drawing a picture of what it looks like. Here's my person. They're throwing a ball. What does that look like? So you're just drawing a sketch of what it looks like. So when you're throwing a ball, just go straight down. It should look something like that. In this function, what does t stand for? What did they tell us t stood for? It's right in here. It's the seconds after the ball's thrown. So t stands for seconds. What does it say h of t stands for? Yep, so it's your height in feet. Cool. Next one says, how high did they start above the ground? looking at the equation, Kimberly found it last time. Who can find what if it's the height above the ground or the starting height? What is that? What are they talking about?
Right.
The y-intercept. How could I find the y-intercept from that equation? So what is this considered on my graph? The y-intercept. And we can see, hey, there's the constant. We know it's 32. They're talking about feet, so 32 feet. That's my first part. Then we go to the next part, and it says, how many seconds after the ball was thrown did it reach its max height? So they're asking for the seconds it reached its max height. What would they indicate there? Would it be your vertex? Would it be your axis of symmetry? Your x-intercept, y-intercept? What are they talking about?
Maximum. Max.
Well, max would be your height, but they don't want to know the height. What do they want to know? Seconds. So which one gives you the time of the max? Axis symmetry. X-intercept when it hits the ground. So how many seconds is your x-coordinate of your vertex? Your axis of symmetry. So that second part says what's it considered on your graph? Axis of symmetry. To get the seconds, what's that equation we use? Because it is going to be a decimal, so usually you would be able to find it on your calculator. But I'm telling you, since it's a decimal, what equation do we use to find the axis of symmetry? Good, negative b over 2n. So what I do is I put this right in my calculator, and I plug in what a and b are. So my a, b, we don't even need C right now, but I'll put C. What was your A in that equation? You'll probably flip the page back. Oh, it's negative 16, 16 and 32. So what would I put right here? Negative, good, 16, and then 2 times my A, which is negative 16. What do you end up getting when you do that? 1/2. Good. What's 1/2 as a decimal? Good. So that at 0.5 at a half a second, that's where the ball reaches its max height. The next one says, what is the ball's height? So what are they trying to find there? The max, right? And so knowing that that is my x-coordinate, I'm just going to rewrite the equation, but instead of the t, I'm going to plug in 0.5. And put that right into your calculator. So when you put that right in, you end up getting 36, which is 36 feet. What is it considered? Your max. When does the ball hit the ground? What am I trying to find there? X-intercept. This one you will be able to find using your calculator table. Or you can practice using your quadratic formula. So either way, you'll get the same answer. So you can either type it into table, it will show up, or you can put it into quadratic formula and just practice doing that. So negative b. And remember, it's going to be positive because I can't throw a ball in like negative 10 seconds. What do you guys end up getting? also just remember, I do give you a lot more practice problems in there, just so like if you need to practice this at home as well, you're able to do that. So make sure you take advantage of that, especially since it's we're wrapping up semester 1. Did anyone get what the x-intercept was? You got the negative one? Did you go up? No. You go up. If you click the enter, you can just go up. Click on it. See a lot of people not on calculators when you still didn't get this answer. And right after this, I'm giving you your ticket out the door. Two. So 2 is your positive x-intercept, so that means when did it hit the ground? In 2 seconds. Perfect. Cool. So now what you're going to do is you're using this problem on your ticket out the door. There's an extra practice there too, if you want to maybe work on this at home before you take your tests coming up. But this is your ticket out the door. So here's the equation. It's saying representing the height of an object above the ground after 2 seconds. So the first part says, what is the height of the object initially thrown from? Where is that graphically? So it's almost like the same sort of question. How many seconds does it take to reach its maximum height? Justify your answer. So they want you telling them what that represents, how you found that. So make sure we got to practice justifying our answer. The last part says, how many seconds have passed when the object hits the ground? Show all your work to justify your answer. These are the type of questions that they're going to ask in the milestone. It is, remember, some of it's open-ended. So show all your work, or it is going to be computer-based. You need to explain what you did. If you use the quadratic formula, if you looked at a table and you found where a certain point is, you got to explain that in the answer. So those are the 3 questions for that to get out the door. So you guys have around like 9 minutes to complete that one question. When you're finished, try another problem if you want, but we are moving on next class. Sound good? Cool. This is your last ticket out the door for this part.